Okay, here comes part 7. Using the compounds below, write 3 different reactions by combining 2 of the 3. So if we call them 1, 2, and 3, we can find 3 different reactions by saying, what happens when these 2 react? What happens when these 2 react? What happens when these 2 react? So let's do them one at a time. Sodium carbonate aqueous solution has to be Na2CO3. I don't really need those parentheses, but there they are. 2 sodiums, each with a charge of 1 plus, 1 carbonate with a charge of 2 minus, is going to react with magnesium chloride. We were given that they're all initially aqueous. Looking at this, I can see a possible double replacement. So sodium will combine with chloride. That's soluble as heck. It's good old table salt. And magnesium carbonate. Looking at the periodic table, I find magnesium in column 2, means it has a charge of 2 plus. Looking at either my polyatomic ion cheat sheet or the solubility rules, I find that carbonate likes to have a charge of 2 minus. So 2 plus and 2 minus. You might be tempted to do the crisscross rule and write Mg2CO32, but remember for ionic compounds we can reduce them to their lowest common denominator. So MgCO3 is correct as written, NaCl is correct as written, MgCl2 is correct, Na2CO3 is correct. The equation isn't quite balanced yet, so let's write a balanced chemical equation by noticing 2 sodiums and 2 chlorines. Balanced nicely here, 2 chlorines, 2 chlorines, 2 sodiums, 2 sodiums, 1 carbonate, 1 magnesium. Bam, we're good. I know that sodium chloride is soluble just from common sense, or you can find the chlorides rule and notice that they're all soluble except a few heavy metal exceptions. And magnesium carbonate. Okay, here's carbonate. All carbonates are insoluble with a few exceptions. Magnesium isn't group 1A and magnesium isn't ammonium, so magnesium is no exception to the general rule that carbonates are insoluble. Therefore, this is a solid, and therefore it forms a precipitate, abbreviated PPT. So, which reactions form a precipitates? This one. Okay, now we'll repeat the process for the next one. Let's combine magnesium chloride with lithium hydroxide. Hydroxides, charge of -1. Lithium's in column 1, so 1 plus, 1 minus. This compound is balanced as written. It's written as aqueous solution, so I won't even bother looking at my rules. They just told me it's aqueous. Going to form magnesium hydroxide and lithium chloride. Charge +1, charge -1, so this is balanced as written. Charge +2, charge -1, which is why there's 2 of them. So this one is balanced as written. I have 2 hydroxides, so I better put a 2 here. Now I have 2 lithiums and 2 chlorines, or chlorides. So 2 lithium chlorides. Okay, now let's decide if these 2 guys are soluble. Chlorides, all soluble except a few heavy metals. Hydroxides, generally insoluble, excepting group 1s, and these 3 weirdos, which are from group 2. However, magnesium is a group 2 that isn't one of these weirdos, so it goes back to the general rule of generally insoluble. So magnesium hydroxide will be a solid, and so there's the precipitate that is formed. Again, PPT abbreviation for precipitate. Okay. Last, we'll react this compound with this compound and see what happens. Oops, I did it again. I wrote parentheses that I didn't really need. This time I'll scratch them out. If I had a pencil, I would erase them. So, sodium carbonate, aqueous, plus lithium hydroxide, aqueous. If they do a double replacement, it'll be sodium hydroxide and lithium carbonate. Carbonate charged 2 minus, lithium charged 1 plus, means I have to do this to balance them. And so if I have to have 2 lithiums, go over there, and now I have 2 hydroxides and 2 sodiums. So now it's balanced. 2 sodiums, 1 carbonate, 2 lithiums, 2 hydroxides, 2 hydroxides. Okay? Hydroxides, insoluble except group 1A. Here's a hydroxide that is a group 1A. Insoluble except group 1A means this is soluble. Lithium carbonate, okay? Carbonates, insoluble except group 1A. Oh, lithium's group 1A. So lithium is an exception to the claim that carbonates are generally insoluble. Therefore, lithium carbonate is soluble. So if this is aqueous and this is aqueous, they both stay in their dissociated or separated ionic states. So there's not really any reaction, and there's certainly no precipitate. And you can stop now and be done, or fast forward to a picture at the end. But what I'm going to do next is draw a picture showing, in this little thing where we sometimes write dissociated ions to remind ourselves of what's going on, that a beaker or dropper full of dissociated sodium ions and carbonate ions surrounded by water, mixing with another beaker where I have lithiums and hydroxides floating around, surrounded by water and not really touching each other. I should have drawn those further apart, but I only have a little space. Mix together to form a big beaker, and in the big beaker you have some sodiums floating around, some lithiums here and there, a carbonate, and that's still clustered, it doesn't come apart, and some hydroxides. And the idea is that every one of these guys is free and roaming around randomly. They're all solutes in a big complicated solution, but there's not really any reaction going on because the sodiums don't pair off with anybody in particular, the lithiums don't pair off, etc., etc. Back in these precipitate reactions, if I had been drawing pictures at the end, I might have shown the precipitate solid down at the bottom. And you weren't asked to do this, but it's just good review. So there's magnesium hydroxide solid, or powder it'll probably look like. And then up here you would have your lithiums and your chlorides floating around, surrounded by the water. So there's some nice pictures. Hope this helps. Good luck on the test.